Hey guys, we're going to review our covalent Lewis dot structures. So we got to remember when we're talking about covalent compounds, we're talking about shared electrons. So we draw that by doing our line, and that line represents a bond and two electrons. So let's keep going and figure out what we do. So I start with CH4, otherwise known as methane. I know that carbon has 4 valence electrons, and I know that the hydrogens, there are 4 of them, and each of them contains 1 valence electron. So that gives me 4 plus 4, so I have 8 electrons. I divide that by 2, and I get 4 pairs. Once again, I know this is a covalent compound, so I know that I'm going to show my electrons being shared. I show that by drawing my line. So I have carbon bonded to a hydrogen, bonded to a hydrogen, bonded to a hydrogen, and bonded to the final hydrogen. So I've placed 4 lines. That is all 4 pairs. I'm out. So now I got to make sure everybody has the correct number of electrons. Well, carbon has 4 different bonds, so that shows all 8. Each hydrogen has 1 bond, and hydrogen, remember, is one of the special elements, and it only has a 1s orbital. It can only hold those 2 electrons, so hydrogen is happy here. Now let's go to our next one, CH2O. So once again, I know carbon has 4 electrons, 4 valence electrons. I know hydrogen, there are 2 of them, and each of them is 1 valence electron. And oxygen has 6 valence electrons. So 4 plus 2 plus 6 is a total of 12 electrons. I divide that by 2 and I get 6 pairs. Now when I go to draw this compound, I know that I've got my carbon and I've got a hydrogen bonded to it, I've got a hydrogen bonded to it, and I've got an oxygen bonded to it. Now when I go to draw this, I've drawn what I can, and I've shown that 3 pairs have gone, so I have 3 pairs left. So I start by putting those electrons on that central atom. So I'm going to put 2 valence electrons on my carbon. That gives me 2 pairs left. So I put 1 pair on oxygen, I put a 2nd pair on oxygen, and I'm out. That's all I've got. Problem is, hydrogen's good, carbon is good, but that oxygen is not. So I need to take the 2 electrons from carbon and slide them in to make a double bond here. That's going to move them from there and put them in here. So when I put them in there, I can now see that I have 8 electrons for oxygen, and I've still got all 8 for carbon. My next example was pH3. Well, I know that my phosphorus is right under nitrogen on my periodic table, so it's got 5 electrons. And I know that the hydrogen, there are 3 of them, and each of them is 1 electron. So I'm going to have my 8 electrons. I divide by 2 and I get my 4 pair. Once again, we're dealing with all covalent compounds, so we know all the electrons are being shared. I'm going to put my phosphorus, I'm going to bond a hydrogen to it, bond another hydrogen to it, and bond that last hydrogen to it. So that gets rid of 3 pairs, so I have 1 pair left. So I put that pair on my central atom. Now phosphorus has all 8, and each hydrogen has 2. I'm done. And my final example was H2S. So I know that hydrogen, there are 2 of them, and each has 1 valence electron. And I know that sulfur is right under oxygen, so it's got 6 valence electrons. So 2 plus 6 gives me my 8 electrons. I'm going to divide by 2 so I can figure out how many pairs I have, and I've got 4 pairs. So I'm going to start with sulfur, and I'm going to bond my hydrogens to it. and it doesn't really matter how I draw it, so I'm going to draw it this way. I've used 2 bonds, so that's 2 pairs. I've got 2 pairs left. Well, I'm going to go to that central atom of sulfur, and I'm going to put my 2 electrons there. Now, this actually looks just like water does if I were to look at the actual sheet. I'm not really worried about that right now, but that's what I've got. If I have any questions, please reach out.